Hello, welcome to the our portion of our video. So here I'm going to be conducting a Pearson's chi-square test with my variables. And just a reminder, a Pearson's chi-square test actually examines the association between two categorical variables, just two. So what I'm really going to be doing is looking at men and their tolerance for bullshit and their perceived respect from their partner. So the first thing I'm going to do, I'm going to load up my libraries. 1, 2. Okay, so these packages allow me to do different things in R. So specifically, I can create a cross table, I can run the Pearson's chi-square test, I can do a log linear analysis. Just depending on those packages, you can do different things. So one thing that I do want to note about Pearson's chi-square is it works on a contingency table. So you want to make sure that you create a contingency table before you run the chi-square test. So the first thing that we're going to do, we're going to create our variables for our contingency table. So the first variable that I have is yes tolerance. So this variable reflects the men who do tolerate bullshit from their partner and receive respect. And no respect, or I'll break it down later. So a total of 153 men tolerated bullshit from their partner, and only 38 of them received respect. So if you subtract 153 from 38, you get the other remaining men who did tolerate bullshit but did not perceive respect from their partner. So I'm going to run that, and it creates our variable. This command here actually is no tolerance. So this variable reflects the men who do not tolerate bullshit from their partner and receive respect or do not receive respect. So a total of 188 men stated that they did not tolerate bullshit from their partner. And of those 188 men, 68 did perceive respect from their partner. The 120 reflects those who did not tolerate bullshit, but also did not receive respect. So those two commands create our tolerance variables for our contingency table. And the next thing that you want to do is use the combine function to combine them into one contingency table. And you can call it whatever you want. I called mine respectable. So the next command shows our contingency table. So just to break it down, this is our yes tolerance. So this reflects the 153 men who do tolerate bullshit and who receive respect and who don't receive it. And the no tolerance column reflects the 188 men who don't tolerate bullshit from their partner and the 68 that do receive respect and the 120 that do not. Number 1 reflects the no perceived respect from their partner. Number 2 reflects the perceived respect from their partner. So in essence, it's just columns and rows. Kind of cool. So the next thing that we want to do, we want to run the Pearson chi-square test using the cross table function. So we run this function, and what we actually get our contingency table, but with other things. Cool beans. Anyways, so just looking at it really quickly, and the main thing that we want to pay attention to is we want to pay attention to those who did perceive respect from their partner. So we're going to be looking at row 2. So a total of 106 men actually stated that they perceived respect from their partner. And of those 106 men, 68 men who did not tolerate bullshit received respect from their partner. And even further, 38 of the 106 men did receive respect from their partner when they tolerated bullshit. So just to kind of break it down a little bit more, 64% of that 106 actually received respect from their partner when they did not tolerate bullshit, more than those who did tolerate it. So what this means that men who did not and absolutely did not tolerate their partner's bullshit actually perceived respect from their partner more than those who did tolerate bullshit. So what this means is that tolerating bullshit will not get you more respect than you see or more respect at all. So don't tolerate it. It's just saying men don't tolerate bullshit and they get respect for it. So that's kind of cool. So now the next thing that we want to look at is our Pearson's chi-square test statistics. Our chi-square statistics. Sweet. So really we want to check to see if it's significant. So we have significance here, people. 0.024 is actually less than 0.05. So this suggests that our findings are indeed significant. And if we want to, we can also have a double check as well. Looking at the Yates continuity correction, and just kind of a refresh on what I mentioned, the continuity correction just subtracts 0.5 from the deviation in the chi-square test. You'll be able to see it if you're doing it by hand, but because we're lazy, R actually does it for us behind the scenes. But what we see here is that it's actually significant. What? So just as a way to follow up, this suggests that our findings are indeed truthful, but we can also look at the Fisher's exact test as well, just to make sure we're on point. Where are we? Which one is it? Hold on, people. I'm looking in the book to make sure I'm looking at the right one, because I'm seeing 3 things. Okay. So the book mentions it's the first one because the numbers match. Because I'm looking at the output in the book, and it's looking at the first one. So I'm going to say we're going to look at the first one as well. Thank you, Andy Fields, for being clear. Okay, so in essence, what the Fisher's exact test tells us, and just a refresher, Fisher's exact test actually uses exact probability. Let me make sure I'm saying it. Yeah. So yeah. Anyways, so we actually have a significant finding here. 0.025 is less than 0.05. Sweet! So in all, we see that in all the highly significant test statistics show us that there is an association between tolerance for bullshit and perceived respect. Yay! Now, I do kind of want to take some time to look at where am I going with this? Right, okay, yeah. So I kind of want to break them down a little bit further in looking at the standardized residuals. So just in breaking them down, we could kind of see it in essence. In essence, the chi-square test, if you've run an ANOVA, you kind of notice that it's similar in that it tells you that there is an association, but it doesn't tell you where the association is. So just looking at this even further, the standardized residuals actually break this down for us. So when you want to look at your standardized residuals, you want to compare them to 1.96, and you want to ignore the minus sign or positive sign. It's just you're really looking at the numbers. But in this case, notice that our numbers are actually less than yeah, they're less than 1.96. So what this means is our findings are basically, well, this is in essence kind of useless. But if you really want to break them down, or just ideally, not even ideally, the point I'm trying to make here is that even though you can find an association between two variables, in order to make it more meaningful than what it is, you want to look into it further. So what we see here, it shows us that none of it is significant. So in essence, it just reflects that there's just something with the numbers. It's not anything with the type of tolerance. It's just numbers. Yeah, and that's my tidbit. Oh yeah, before I get on my part two of the rant. So as far as assumptions go, we can look to see if we have expected frequency that's greater than 5, and we do, because our smallest expected frequency is 47. That's definitely bigger than 5. So really, the tidbit that I want to say is just because you have an association doesn't really mean it's meaningful. You have to break that stuff down. That's my second tidbit. We can also look at the odds ratio, and the odds ratio just gives us a sense of the magnitude of our variable, of our predictive variable on the outcome variable. Where is it? There we are. So you see it's relatively small, but in essence, it's like the odds of men receiving respect from not tolerating bullshit is 1.71 times greater than if they had shown tolerance for bullshit. That's all that is. So yeah, that's pretty much it for the Pearson's chi-square test. In the next video, I'm going to do a log linear analysis, but there's a special twist with it. And that's it, folks.